Question number 12 of the worksheet. Probability that Hank goes swimming on a day is 0.2. On a day when he goes swimming, the probability that Hank has burger for supper is 0.75. Acha. So let's just fill up this tree diagram on the go. So probability that he goes swimming is 0.2. That means the probability that he does not go swimming is going to be 0.8. And on the days he's going swimming, probability that he will eat a burger later is 0.75. So the probability he will not eat a burger would be 0.25. And then if he does not go swimming, probability that he eats a burger is going to be X, and the probability that he's not going to eat a burger is going to be 1 minus X. Okay, this information is shown on the following tree diagram. The probability that Hank has a burger for supper is 0.5. Okay, so probability of eating a burger is 0.5. So if he goes to the swimming and he eats burger, that's one of the cases. And if doesn't go for a swim and still eats a burger, that's the second case. So we multiply and add these probabilities. So part 1. 0.2 times 0.75 plus 0.8 times X. And we're given the answer for this. It is 0.5. And you have to find X from here. This you will do on your own and you'll see that X comes out to be 0.4375. Part 2. Given that Hank has burger for supper, so probability something given burger, find the probability that he went swimming that day. So I'm going to write S here. So now the formula for conditional probability would be probability that he goes swimming and he eats a burger divided by probability that he eats a burger. So we already found the probability that he eats a burger in part 1. So the denominator is going to be, no, we did not find that in part 1. In part 1, we found X. That probability of eating burger would be 0.5 from the given data. So B is probability of eating a burger is 0.5, which we write in the denominator. Numerator, maybe we have to write probability of going for swim and eating a burger. That's going to be the green line, 0.2 times 0.75. This comes out to be 0.3. Please ask if you have any questions. Question 13. Okay. 2 fair dice are thrown. Event A is the score differ by 3 or more. Find the probabilities of the event A. Okay. 2 fair dice are thrown. And we have to find or use all the outcomes where the difference is 3 or more between the results of the 2 die thrown. So can you give me an example of the case where you throw 2 dice and the values at the top of the die differ by 3 or more? Give me an example. एक डाइस पे 1 आ गया और सेकंड डाइस पे 3 और मोर, तो 4 आ गया सेकंड डाइस पे, दैट्स वन ऑफ द केस। और एक पे 1 आ गया, एक पे 5 आ गया, और एक पे 1 आ गया, एक पे 6 आ गया। या लेट्स स्वैप देम, फर्स्ट वाले पे 4 आ गया, सेकंड पे 1 आ गया, 5 1 6 1। There's so many cases. Instead of stating them separately, I recommend using a possibility diagram like we used to do in O levels. Possibility diagram. Possibility diagram is a quick way of checking all the uh, results simultaneously. So first die could be 1, 2, 3, 4, 5, 6 at the top, and the second die could give 1, 2, 3, 4, 5, and 6 at the top. So that's going to be a total of 36 outcomes, 6 times 6. Okay. So अब इसमें this is the case that the both the die have 1 at the top. So ये तो हमारा वो case नहीं है because the difference is not 3 or more. सेकेंड केस इज के एक पे 1 आया है और एक पे 2 आया है, ये भी डिजायर्ड केस नहीं है, डिफरेंस इज नॉट 3 और मोर. So this is the case where the difference would be 3 or more. Similarly, 1 5 and 1 6. 2 1 does not fit in the category. 2 2 भी नहीं, 2 3 भी नहीं, 2 4 भी नहीं, 2 5 fit in होती है. So 2 5 is correct or fits in event A, and similarly 2 6. 3 1 9, 3 2 9, 3 3 9, 3 4 भी नहीं, 3 5 भी नहीं, और 3 6 भी नहीं. 3 6 does have a difference of 3. 4 1 does not fit in the category. 4 2, 4 3, 4 4, 4 5, and 4 6. 4 1 fits in the category. The difference is 3. Okay. 5 1 has a difference of 4, which is more than 3. 5 2 has a difference of 3. So not 5 3, not 5 4, not 5 5, and not 5 6. Okay. And 6 1 falls in the category. 6 2 does, 6 3 does, but not the remaining 3. Okay. So that is 1 2 3 4 5 6 7 8 9 10 11 12. 12 out of 36 cases. So the first probability is going to be 12 by 36, which is 1/3. कोई क्वेश्चन है इधर? Okay. Part 2. Event B is the product of the scores is greater than 8. Find the probability of event B. अब हम देखते हैं कि which product is going to be greater than 8. ये तो नहीं होगा, ये भी नहीं होगा, ये भी नहीं होगा, ये फर्स्ट केस में तो कोई भी नहीं होगा. So none of them. Then 2 times 4 is 8, but not greater than 8. 2.2 times 5 is greater than 8. So ये
मैम
वाला
वैसे 10 over 36 नहीं है पहले का?
क्यों 10 क्यों? मेरे पास तो 12 आ रहे.
मैम देखे राइट कॉर्नर में. अच्छा नहीं, नेवर माइंड.
ठीक है, आपने कोई 2 मिस किए हैं, इसीलिए पॉसिबिलिटी डायग्राम थोड़ी ज्यादा एक्यूरेटली आपको बता देती है कि कितने होंगे। आप खुद से गेस कर रहे हो ना, तो इट्स वेरी लाइकली कि आप कुछ मिस कर दो। ठीक है, तो अब हम देख रहे हैं कि किसका प्रोडक्ट है वो ग्रेटर देन 8 है। तो एक 2 टाइम्स 5 हो गया, 2 टाइम्स 6 भी हो गया, सो इधर भी आई एम गोइंग टू मेक अ लाइन। ओके, फिर 3 3 3 टाइम्स 4, 3 टाइम्स 5, 3 टाइम्स 6, फिर हो गया 4 टाइम्स 3, 4 टाइम्स 4, 4 टाइम्स 5, 4 टाइम्स 6, फिर 5 टाइम्स 2, 5 टाइम्स 3, 5 टाइम्स 4, 5 टाइम्स 5, 5 टाइम्स 6, और फिर ये 6 टाइम्स 2 टाइम्स 3 टाइम्स 4 टाइम्स 5 टाइम्स 6। तो ये हो गए 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 20 out of 36. So 20 by 36 is going to be the probability, which is 12 by 6, 18, 10 by 18, which is 5 by 9. You may or may not simplify the answer. It does not matter. Okay, part 3. State with the reason whether events A and B are mutually exclusive. Mutually exclusive events क्या होते थे? In terms of sets, they do not have an intersection. So we have intersecting region. देखो ये केस, इसमें 2 और 5 में इवेंट ए में भी फिट हो रहा है, इवेंट बी में भी फिट हो रहा है। 2 और 6 इवेंट ए में भी फिट हो रहा है, इवेंट बी में भी फिट हो रहा है। बेसिकली जिसपे मैंने दोनों रेड और पर्पल लाइन लगाई हैं वो ओवरलैपिंग पार्ट है। सो ये नहीं है म्यूचुअली एक्सक्लूसिव। सो स्टेट विद द रीजन, तो आप लिखोगे प्रोबेबिलिटी ए इंटरसेक्शन बी इज इक्वल्स टू, क्या हमारे पास आ रहा है, 1 2 3 4 5 6, 6/36, which is not equals to 0. So not mutually exclusive. Question 14. Jamie is equally likely to attend or not attend a training session before a football match. If he attends, he is certain to be chosen for the team which plays in the match. If he does not attend, there's a probability of 0.6 that he is chosen for the next team. Tree diagram बना लेते हैं. Jamie is equally likely to attend or not attend a training session. So attends TS, which is the training session, does not attend training session. So the probability that he attends the training session is he's equally likely to attend or not attend. That means this is 0.5 and this is 0.5 as well. If he attends, he is certain to be chosen for the team. So chosen for team or not chosen for the team. Okay. So if he attends the training session, that then for sure he gets chosen. So this is going to be 1 and this is going to be 0. If he does not attend, there is a probability of 0.6 that he will be chosen. So I'm writing C for chosen, 0.6, and NC for not chosen. This is going to be 0.4. आप पूरा लिखोगे, chosen and not chosen. Find the probability that Jamie is chosen for the team. So that would be this case, that he attends the training session and is chosen, or it will be the case that he does not attend the training session and is chosen. So that's going to be 0.5 times 1 plus 0.5 times 0.6, which gives 4/5 or 0.8. Part 2. Find the conditional probability that Jamie attends the training session given that he was chosen for the team. Okay. Find the conditional probability that Jamie attends the training session given that he was chosen for the team. So given, chosen, and at the top we're going to write attend training session. So I'm going to write attends training session. Okay. So probability that he attends the training session and gets chosen for the team upon probability that he gets chosen for the team. Okay. So the numerator would be the blue line 0.5 times 1 upon probability he gets chosen for the team. We've already found that in part 1. That is 0.8. So this would come out to be 0.625. Any questions here? Question 15. Box A contains 5 red pens and 1 white clip. Paper clips. 5 red paper clips and 1 white paper clip. Box B contains 7 red paper clips and 2 white paper clips. Let's quickly draw this. So box A है एक, and a box B. 5 red and 1 white. I'm doing gray here. नजर ही नहीं आ रहा gray. Let's use some other color. Okay. And box B contains 7 red, 1, 2, 3, 4, 5, 6, 7, and 1 gray. Sorry, 2 whites, not gray, whites. Okay. So 1 paper clip is taken at random from box A and transferred to box B. 1 paper clip is then taken at random from box B. Find the probability of taking both a white paper clip from box A and a red paper clip from box B. Okay. So you have to find the probability that from box A, a white paper clip is drawn, and from box B, a red paper clip is drawn from box B. Okay. So what is the probability of getting a white paper clip from box A? That's 1 out of 1, 2, 3, 4, 5, 6 chances. So that's going to be 1/6 times Now this white paper clip is transferred here. So you have 3 white paper clips here, but we have to find the probability that a red one gets chosen here. So how many reds are there in this box? 1, 2, 3, 4, 5, 6, 7. 7 out of 10. So 7 by 10. Which gives 7 upon 60. Part 2. Find the probability that the paper clip taken from box B is red. Okay. So you could get a red from box A and then a red from box B, or you could get a white from box A and red from box B. So you have to find both these probabilities and add them. एक तो हमने ऊपर वाले part में कर लिया, so we won't be doing that again. So we found the probability that the first one is white from A and the second one is red from B. So, or probability of getting a red from A and then again a red from B. So this is 7 by 60 already. Plus red from A would be, there are 5 red.
मैम ये ट्रांसफर ऐसे रैंडमली हुआ वैसे ये पेपर पे क्लिप समझ नहीं आई थी इसका क्वेश्चन की स्टेटमेंट।
जो भी इधर से चूज होता है वो उसमें चला जाता है। सो उन्होंने कहा है
ठीक है
व्हाइट, ठीक है, पहले व्हाइट चूज हुआ था तो व्हाइट की तो प्रोबेबिलिटी वही आ गई 1/6। पार्ट 1 करा रही हूँ, आप 1 पूछ रहे हो 2 पूछ रहे हो?
मैम ओवरऑल ही पूछ रहा था, वो कॉन्सेप्ट वो क्लियर नहीं था
तो यही
इसलिए।
है कि जो इधर से आया वो बॉक्स बी में चला गया। तो जब इसमें से व्हाइट आया था
ठीक है मैम।
तो वो यहाँ पे 3 वाइट हो गए, तो टोटल फिर 9 की जगह 10 आ गए इस बॉक्स में। ठीक है, ओके,
ठीक है।
बैक बैक टू दिस। फर्स्ट में से रेड आई है, सो देर आर 5 रेड out of 6, so 5/6 times, and now that red has been transferred to this bag. So now there are a total of 8 reds and there are a total of 10 paper clips in box B. So that would be 8 upon 10. And collectively, this is 47/60. Part 3. Find the probability that the paperclip taken from box A was red, given that the paperclip taken from box B is red. Okay, let me first clear this. There. So, part 3 is a question on conditional probability. Find the probability that the paperclip taken from box A was red. So, probability red from box A given the paperclip taken from box B is red. So red from B as well. So that is probability red from A and red from B. ये हमने यहाँ किया हुआ है, ये रहा. So we won't be doing that again. We'll be using the same product upon probability of getting a red in B. वो भी ये हमने part 2 का जो answer है, that is the answer for this. So the denominator is going to be 47 upon 60. And the numerator is going to be the yellow part, 5/6 into 8/10. This comes out to be 40 upon 47.
वन नहीं आता।
क्या आता है? मेरे पास
नहीं
कैलकुलेटर
आता।
नहीं है। बट मेरे पास लिखा हुआ आंसर 40/47 1 आएगा, 1 तो नहीं
नहीं
आएगा।
नहीं मैम, सही है।
1 तो मैक्सिमम प्रोबेबिलिटी होती है, इसका मतलब है हमेशा ये होगा, बट ये तो पॉसिबल नहीं है। Okay, we're not doing part 4 for now. Uh, it's from the topic probability distribution, which we haven't discussed yet. चलिए क्वेश्चन 16 कर लेते हैं। Fabio drinks coffee each morning. He chooses Americano, cappuccino और latte. इसको ट्री डायग्राम बना देते हैं। Americano, cappuccino और latte with the probability 0.5, 0.3 and 0.2. If he chooses Americano, he drinks it immediately. So drinks immediately with a probability 0.8, or leaves it to drink later. Leaves for later is 0.2. अब इसको मैं लिखूंगी drink immediately आगे, और इसको मैं लिखूंगी leave for later LL. Okay. If he chooses cappuccino, he drinks it immediately with a probability of 0.6. That means he leaves it for later with a probability of 0.4. And if he chooses latte, he drinks it immediately with a probability of 0.1, drinks immediately, and leaves it for later with a probability of 0.9. Okay. Find the probability that Fabio chooses Americano and leaves it to drink later. So Americano and leaves it to drink later. This would be 0.5 times 0.2, which is 0.1. Fabio drinks his coffee immediately. Find the probability that he chooses latte. So this is a question on conditional probability. He drinks his coffee immediately. So given immediate, drinks immediately, find the probability that he chooses latte. So L. So probability of choosing latte and drinking it immediately upon probability of drinking any coffee immediately. Okay. So latte and immediately would be 0.2 into 0.1. Upon drinking any drink immediately would be Americano, drinking immediately, cappuccino and drinking it immediately, or latte and drinking it immediately. So sum of all these three products, 0.5 into 0.8 plus 0.3 into 0.6, and one more plus 0.2 into 0.1. And this should give you 1/30 is the given answer. Okay. Let's end the lesson here, and we're more or less done with the topic of probability. This will come up again when we do probability distribution. Inshallah, tomorrow we'll start a new topic, permutations and combinations. Okay, see you tomorrow. Allah Hafiz.